For poets, artists, and thinkers, Atlas becomes a symbol of cosmic migration, of journeys without return, of silent endurance across unfathomable distances. Its image fuels metaphor and story as much as it fuels equations and simulations. That dual resonance, scientific and humanistic, cements its place as one of Webb's most captivating early triumphs. The timing of Atlas's arrival is itself a fascinating coincidence. For decades, astronomers speculated that interstellar objects should occasionally drift through our neighborhood, but none were confirmed until just a few years ago. The fact that Atlas appeared after Oumuamua and Borisov suggests such encounters may be more common than once believed. Webb's image confirms that we are now technologically prepared to study these visitors in depth, capturing not just fleeting glimpses, but enduring portraits. This changes the narrative from rarity to opportunity, shifting our mindset from luck-driven discoveries to strategic observation campaigns. Future surveys may prioritize rapid detection of interstellar objects, so Webb and its successors can turn their gaze quickly, ensuring no traveler escapes without thorough study. The size and resilience of Atlas raise intriguing questions about galactic debris populations. If a multi-kilometer object can cross interstellar space intact, how many such bodies must be drifting invisibly between stars? The answer may reshape our understanding of cosmic abundance. The galaxy could be teeming with interstellar wanderers, silent emissaries carrying chemical diversity across systems. Webb's image of Atlas transforms this abstract idea into reality. The next logical step will be quantifying how many more like it are likely to pass by, and whether Earth itself has been influenced in the past by such arrivals. It is possible that interstellar objects striking Earth in its early history delivered crucial compounds that contributed to the emergence of life. Webb's image is therefore not only a portrait of a passing traveler, but a reminder of ancient deliveries that may have shaped our own existence. The engineering precision behind Webb deserves closer examination because it highlights the enormity of what has been achieved. Aligning a segmented mirror in the cold vacuum of space, fine-tuning instruments to detect photons from faint sources, and stabilizing the platform against even the slightest drift were all monumental challenges. The fact that such a machine can then capture an interstellar object with clarity is a triumph of human ingenuity. This success underlines the interconnectedness of disciplines. Engineers, physicists, chemists, and computer scientists all contributed to a tool capable of peering into the unknown. Every pixel of the Atlas image is thus a human achievement, as much as a cosmic revelation. The implications for planetary science are especially significant. Atlas provides a data point that challenges models of solar system development. Traditionally, scientists study comets and asteroids to infer how our own system evolved. But with Atlas, we have a direct sample of another system's history. Its features can be compared against solar system bodies, highlighting similarities and differences that reveal universal versus local processes. For example, if Atlas's composition contains isotopic ratios distinct from those in solar comets, it would suggest variations in the stellar nurseries where they formed. Conversely, similarities would point to a common galactic recipe for planetary formation. Either outcome is invaluable, expanding our understanding of the processes that shape habitable environments. Beyond pure science, the capture of Atlas by Webb may catalyze discussions about interstellar missions. Projects like Breakthrough Starshot envision sending nanocraft to other stars using light sails, but these remain in the realm of future ambition. In the nearer term, interstellar objects passing through our solar system could serve as natural targets for robotic missions. If technology is developed to rapidly launch probes, we could someday intercept a visitor like Atlas, collecting samples and performing in situ analysis. Webb's image is a precursor to such endeavors, a reminder that opportunities to touch another star system's material might pass within our reach more often than we expect. The societal impact of Webb's image of Atlas extends even further. In classrooms, it will inspire a new generation of scientists who see not just distant galaxies, but tangible travelers from beyond our sun. In museums and planetariums, the image will stand as a visual centerpiece, sparking conversations about humanity's place in the galaxy. In policy-making circles, it may influence funding decisions toward astronomy and space exploration as public appetite for discovery grows in response to such iconic achievements. Webb's capture of Atlas is therefore not just a scientific milestone, but a cultural catalyst, nudging societies toward greater engagement with the cosmos. On a philosophical plane, the image embodies themes of impermanence and connection. Atlas will not linger. Its path ensures it will soon be gone, perhaps never to be observed again. Yet for this brief moment, its image has been etched into human knowledge, binding our story with its journey. This interplay between transience and permanence mirrors the human experience, short-lived on cosmic scales, yet capable of leaving enduring marks through observation, thought, and imagination. The Webb image crystallizes that paradox in a way few discoveries can. Looking ahead, the study of Atlas will undoubtedly inspire refinements in observational strategy. Astronomers may recalibrate surveys to catch future interstellar visitors earlier in their approach, giving Webb or other observatories more time to collect data. Simulation models will integrate what we have learned about Atlas's composition and behavior, predicting what other interstellar bodies might look like. Future telescopes like the planned LUVOIR or HABEX will build on Webb's achievements, offering even sharper views and broader wavelength coverage. In many ways, Atlas is a herald of the science to come, demonstrating both what we can achieve now and what we must prepare for in the future. The narrative of 3I/Atlas, as revealed by Webb, also challenges us to rethink our definitions of home and foreignness. Here is an object that is not ours, that does not belong to our sun, and yet for a moment, it becomes part of our observational universe. It blurs the boundaries between systems, reminding us that space is not neatly divided, but is instead a continuum of interactions and exchanges. Atlas is both alien and familiar, distant and intimate, fleeting and eternal. Its image is a reminder that the galaxy is not a collection of isolated islands, but a web of constant motion where material drifts and mingles across the stars. The James Webb Space Telescope's image of 3I/Atlas continues to resonate because of its multidimensional significance. What the world has seen is not just an astronomical observation, but a direct glimpse into the mechanics of galactic evolution. By studying an object that has crossed from one star system to another, astronomers gain a rare opportunity to connect theories of planetary formation, stellar dynamics, and interstellar migration into a single observable case. The richness of this discovery allows for further exploration from angles not yet considered, each one adding depth to the narrative of Atlas and its passage through our solar system. One of the least explored aspects of Webb's observation is how 3I/Atlas contributes to our understanding of galactic ecology. Galaxies are not static collections of stars. They are dynamic ecosystems where stars form, planets emerge, and debris migrates. The ejection of interstellar objects is a natural part of this process. When stars interact with one another in crowded clusters, or when giant planets gravitationally scatter planetesimals, vast numbers of bodies are flung into interstellar space. Most of these wander invisibly, but every so often, one drifts into our line of sight. Webb's image of Atlas, therefore, does more than document a visitor. It confirms that our galaxy is laced with nomadic bodies, silent carriers of material from one system to another. This makes the Milky Way less a collection of isolated solar systems and more a network linked by the constant exchange of matter. Another dimension to the discovery lies in what 3I/Atlas tells us about the diversity of planetary system outcomes. Our solar system is just one experiment in cosmic architecture, with gas giants in stable orbits and smaller planets arranged in a relatively orderly manner. Other systems, as exoplanet surveys reveal, can be chaotic, with super-Earths skimming close to their stars and gas giants roaming erratically. Atlas's very existence as an interstellar traveler hints at a past in which its parent system underwent violent reshaping. Perhaps a migrating giant planet destabilized an outer belt, ejecting icy bodies by the thousands. Perhaps a nearby stellar flyby stirred the outer regions, sending debris scattering into interstellar darkness. Webb's image captures not just Atlas itself, but the outcome of these distant, unseen dramas. Each scar on its surface may carry the fingerprint of a system unlike our own, making Atlas a geological ambassador of alien architectures. Webb's contribution also highlights the evolving philosophy of astronomy itself. Traditionally, the field was concerned with charting stable patterns, planetary orbits, stellar lifetimes, galactic rotations. Interstellar objects like Atlas shift the paradigm by emphasizing transience. Here is a body that will never circle back, never be catalogued into long-term prediction models, never belong permanently to our observational universe. Its very nature is fleeting. And yet, it offers a wealth of knowledge in its brief passage. This demands a new scientific mindset, one that values immediacy, rapid response, and flexibility. Observatories must pivot quickly, instruments must adapt, and theories must be revised in real time. Webb's image of Atlas exemplifies this shift, showing that astronomy in the 21st century is as much about catching the ephemeral as it is about charting the eternal. A key area of exploration spurred by Webb's observation is the potential connection between interstellar objects and panspermia theories. Panspermia suggests that life's ingredients, or even microbial life itself, could be transported across star systems via comets, asteroids, or dust. With Webb detecting unusual organics on Atlas, the idea gains fresh support. These molecules, preserved through interstellar cold and radiation, could represent chemical toolkits capable of sparking biology when delivered to a suitable planet. The fact that Atlas carries them demonstrates that interstellar transfer of organics is not just theoretical. It is happening. While not evidence of life itself, it is proof of a delivery mechanism. The implications ripple outward. If planets like Earth are seeded not only by local comets but also by foreign wanderers, then life may be a galactic phenomenon rather than a planetary accident. Webb's image thus becomes a cornerstone in one of the most profound debates of all: how and where life begins. The interplay between Webb's findings and exoplanet research is another fertile avenue of thought. Exoplanet atmospheres are probed by Webb to detect gases like methane, carbon dioxide, and water vapor. These signatures tell us about the chemistry of distant worlds. Now, with Atlas, Webb has added a complementary perspective: the solid remnants of planetary formation themselves. Studying both exoplanet atmospheres and interstellar objects creates a fuller picture of other systems. Where atmospheres reveal surface and climate conditions, interstellar debris reveals the building blocks that form those surfaces. Together, they paint a three-dimensional portrait of alien systems, giving scientists tools to compare not just stars and planets, but the debris that drifts between them. There is also the question of galactic time scales. The image of Atlas shows us an object that may have traveled for millions, even billions of years before arriving here. During that time, it would have passed through interstellar clouds, skirted the edges of nebulae, and perhaps been irradiated by supernova shock waves. Its surface chemistry may record these encounters, preserving a timeline of galactic events. Webb's sensitivity allows astronomers to begin decoding that record, teasing out whether certain isotopes or compounds are evidence of cosmic rays, star-forming regions, or explosive stellar deaths. In this way, Atlas is not merely a snapshot of a distant system, but a traveler carrying an itinerary of galactic history etched into its crust. One cannot overlook the role of gravitational choreography in bringing Atlas to our notice. For an object ejected from another star system to wander into ours, its trajectory must intersect with the Sun's gravitational sphere of influence, an event that is statistically rare. Webb's capture demonstrates just how delicate these celestial dances are. Small shifts in angle or speed could have sent Atlas drifting far from our reach. Instead, the universe conspired to place it within sight of humanity's most advanced telescope. That alignment highlights the remarkable luck involved in cosmic discovery, but also the importance of preparation. Without Webb's readiness, Atlas would have remained a blur. With Webb, it becomes a case study in celestial dynamics. The discovery of exotic organic molecules in the spectral data adds another layer of fascination. These organics differ from those typically seen in solar system comets, suggesting they formed under conditions alien to our local environment. Their spectral signatures hint at chemical bonds and structures that may have arisen under different stellar radiation, elemental abundances, or temperature profiles. Some may even be entirely new to science, providing chemists with fresh puzzles about how complex molecules form and persist in deep space. These compounds underscore the possibility that life's raw materials are not confined to a single star system, but are instead widespread, varied, and cosmically abundant. Such a realization has profound implications for astrobiology, as it suggests that the seeds of life are strewn across the galaxy, ready to take root wherever conditions allow. The James Webb Space Telescope's first real image of 3I/Atlas will be studied for decades, cited in textbooks, and remembered as the moment when interstellar objects ceased to be fleeting mysteries and became resolvable realities. For all its technical brilliance, the image also resonates on a simple, profound level. It shows us that the galaxy is alive with movement, connection, and discovery waiting to be made. Thank you for your interest in this remarkable achievement. NASA's James Webb Space Telescope achieved a groundbreaking milestone by capturing the first high-resolution image of 3I/Atlas, an interstellar object passing through our solar system. This marks a pivotal moment in observational astronomy and our understanding of mysterious visitors from beyond our stellar neighborhood. The James Webb Space Telescope has delivered an unprecedented view of the cosmos. Its first detailed image of 3I/Atlas represents more than just another astronomical achievement. It offers humanity a clear window into the nature of objects that occasionally traverse our solar system from interstellar space. Until now, these cosmic wanderers were fleeting apparitions that telescopes struggled to observe before they vanished into darkness. 3I/Atlas is only the third confirmed interstellar visitor ever detected. What Webb has provided is an extraordinarily sharp image that delivers both visual and scientific clarity. The veil over this cosmic stranger has finally been lifted, revealing features that inspire both wonder and deep scientific inquiry. The image radiates with Webb's characteristic precision, showing Atlas in ways that were simply impossible with earlier technology. Previous interstellar objects like 1I/Oumuamua and 2I/Borisov were observed with limited instruments that provided only basic clues about their trajectories and surface compositions. Their true physical nature remained largely mysterious. With 3I/Atlas, Webb's infrared capabilities have penetrated layers of mystery. Positioned beyond Earth's atmosphere, the telescope suffers no atmospheric distortion. Its instruments capture faint signals and subtle contrasts that ground-based observatories cannot manage. The result shows Atlas not as a dim streak against stars, but as a distinct body with discernible surface features, spectral details, and a visible coma of outgassing particles. One of the most striking revelations is the texture of Atlas's surface. For years, scientists debated whether interstellar objects would resemble icy comets or rocky asteroids from our solar system. The captured image reveals a surface with reflective patches suggesting volatile ices actively sublimating under solar influence. Simultaneously, darker scars and irregular shapes hint at impacts and fractures accumulated during its long journey through deep space. This duality suggests Atlas might be a hybrid, carrying characteristics of both rocky and icy bodies. Such an object could only originate in the outer reaches of a distant star system, later ejected into interstellar space through gravitational encounters. The visible coma, a faint but distinct halo of gas and dust surrounding the object, transforms Atlas from merely a rocky body into an active traveler. This halo, though not as prominent as those surrounding large solar system comets, speaks volumes. Even after crossing the void between stars, Atlas has preserved volatile compounds now being released under our sun's warming touch. This provides astronomers with a pristine sample of interstellar material, unaltered by billions of years of solar radiation or planetary encounters. Atlas is essentially a time capsule from another star system, holding unprocessed remnants of its original birthplace. Webb's instruments extended beyond imaging. Its spectrographs recorded the unique chemical signature of 3I/Atlas, breaking down reflected and emitted light into revealing bands. Early analysis points to compounds both familiar and exotic. Water ice appears abundant, intermixed with unusual organic molecules rarely seen in solar system comets. These molecules could reveal how chemistry unfolds in environments vastly different from our own. Even more compelling is the possibility that such compounds are universal seeds of prebiotic chemistry, capable of initiating life when delivered to hospitable worlds. If Atlas carries such molecules, it strengthens the case that interstellar bodies are messengers of cosmic chemistry, distributing life's ingredients across the galaxy. The sheer size of Atlas adds another layer of fascination. Unlike Oumuamua, a slender, elongated fragment only a few hundred meters long, or Borisov, a relatively small comet-like body, Atlas measures several kilometers across. This makes it more akin to a full-fledged comet nucleus than a fragment. The scales suggest it survived violent ejection from its parent system intact, a process involving dramatic gravitational interactions with giant planets or passing stars. Seeing such a large object traverse the gulf between stars underscores how dynamic planetary systems can be. If one large object can escape, countless others likely do as well, turning interstellar space into a quiet highway of wandering debris. The orbit traced for 3I/Atlas confirms its interstellar origin beyond doubt. Webb's precise measurements show a hyperbolic path curving through our solar system only once before departing forever. Unlike comets bound to the sun's gravity, Atlas is not returning. It is simply passing by, and Webb's image has frozen that passage in unprecedented detail. This knowledge adds poignancy to the discovery. This is a fleeting visitor we will never see again. Yet it also emphasizes the importance of the Webb telescope in capturing such ephemeral moments. Without its capabilities, Atlas might have slipped by with minimal observation, just another blurred entry in astronomical catalogs. Instead, it now stands as a comprehensive case study in the birth, evolution, and survival of interstellar wanderers. Astronomers are already drawing comparisons between Atlas and previous interstellar objects. Where Oumuamua strange elongated shapes spark theories of artificial origin, Atlas appears more conventional, though still exotic in detail. Where Borisov behaved like a typical comet, Atlas presents a hybrid personality. These contrasts are invaluable because they highlight the diversity of objects flung from other star systems. No two interstellar visitors may ever be identical, reflecting the infinite variety of planetary system architectures across the galaxy. Beyond astronomy, the implications ripple outward into other scientific fields. Planetary formation theories must now account for the fact that entire kilometer-scale objects can be expelled and travel interstellar distances intact. Astrobiology gains new data on how life's chemical precursors might be disseminated across vast expanses. Cosmochemistry gains a rare laboratory sample preserved from beyond our solar cradle. Even philosophy finds resonance here as humanity contemplates that matter from unknown stars is brushing past us, tangible and observable in real time. The visual impact should not be understated. For the public, the photograph of 3I/Atlas is an invitation into the profound. Unlike theoretical models or blurry images, this is a real, sharp portrait of an interstellar traveler glowing faintly against a tapestry of stars. It makes the vastness of the galaxy suddenly intimate. Somewhere, a planetary system gave birth to this object. Somewhere, forces tore it away, sending it on a trajectory that happened to intersect our small solar neighborhood. To look at the image is to see a story etched in rock and ice, a journey spanning millions of years and uncountable distances. Webb's achievement also energizes conversation about how humanity might interact with such objects in the future. Today, we observe them from afar, content with the light they reflect. But as imaging improves and the catalog of interstellar visitors grows, the notion of sending probes becomes more tangible. A mission to intercept and study such a body up close could reveal even more about their structure and composition, bridging the gap between distant observation and direct exploration. For scientists working on Webb, this moment validates decades of effort. The telescope was designed not only to peer back in time to the early universe, but also to examine objects within our own galactic neighborhood with unrivaled detail. Capturing Atlas blends those missions beautifully, a local observation with cosmic implications. Every pixel in the image represents precision engineering, flawless deployment, and patient alignment. To see it pay off with such a discovery is a triumph for the entire scientific community. As researchers continue analyzing data from Webb, more layers of Atlas's story will emerge. Models of its thermal properties, rotation, and surface erosion are already being refined. Every aspect adds to a growing portrait of an interstellar visitor, not just as a curiosity, but as a critical data point in understanding the galaxy's restless dynamics. The image Webb revealed is not a conclusion, but a beginning, a foundation upon which years of study will be built. The wonder of 3I/Atlas lies not only in its uniqueness, but in what it represents. It is proof that interstellar space is not empty but alive with travelers, each carrying a story from a different star. Webb's image crystallizes that reality in a way words alone cannot. For the first time, humanity can look at an interstellar object and see it clearly, with detail that makes it real and present rather than abstract and theoretical. That shift from the unknown to the tangible is transformative. At a human level, there is something deeply humbling in Webb's achievement. To know that light from an object formed around another star has been captured and rendered into an image we can see today connects us more deeply to the cosmos. It reminds us that we are part of a galactic web of matter in motion, that our solar system is but one node in a sprawling stellar tapestry. The image of 3I/Atlas is a reminder that the universe is not distant and disconnected but immediate, dynamic, and in dialogue with us. The James Webb Space Telescope has not just revealed a picture. It has opened a doorway into another system's history, carried across interstellar space in the form of a wandering body. The first real image of 3I/Atlas will be studied for decades, cited in textbooks, and remembered as the moment when interstellar objects ceased to be fleeting mysteries and became resolvable realities. For all its technical brilliance, the image also resonates on a simple, profound level. It shows us that the galaxy is alive with movement, connection, and discovery waiting to be made. The unveiling of this image has set off a cascade of new questions, explorations, and contemplations that stretch across the scientific and cultural landscape. This moment represents a dramatic intersection of technology, discovery, and imagination. To appreciate the depth of what Webb has shown us, it is worth examining the intricate details and broader context surrounding this unprecedented observation. Every frame of light collected from Atlas is not just data. It is an invitation to rethink what we know about interstellar space, planetary systems, and the very fabric of galactic interactions. The image of 3I/Atlas is particularly remarkable when considered against the backdrop of the telescope's engineering. Webb's segmented mirror, spanning over 6 meters in diameter, was designed to capture faint and distant phenomena with unparalleled sensitivity. This capacity was expected to yield breathtaking portraits of early galaxies, nebulae, and exoplanet atmospheres. What it has done with Atlas is something unexpectedly personal, bringing into sharp focus a solitary traveler from beyond the sun's influence. The clarity of this capture illustrates the versatility of Webb's instruments. Not only can it decode the faint glow of galaxies billions of light-years away, but it can also deliver piercing details of an object that will brush past our cosmic doorstep before vanishing forever into the void. This dual ability bridges the cosmic scale with the immediate, the ancient with the fleeting. The scientific community is particularly enthralled with how Webb's mid-infrared instruments have mapped Atlas. Unlike visible light, which shows shapes and surfaces, the infrared view penetrates thin veils of dust and highlights thermal differences across its body. From this, astronomers can discern areas where sublimation is active, patches on the surface that release jets of gas and particles into surrounding space. These patches reveal where volatile ices are concentrated, giving researchers insight into how the body is structured beneath its crust. The image shows bright spots that almost sparkle against the darker background of its rocky face, each a signature of volatile activity. These findings are critical in modeling the object's internal composition, helping us understand how it was formed and what processes preserved it during its interstellar journey. Another compelling element of Webb's view lies in its rotational features. The telescope's instruments are precise enough to detect asymmetries in surface brightness, which in turn reveal how Atlas rotates on its axis. Unlike the relatively predictable rotation of many asteroids and comets we know, Atlas seems to tumble in a complex, almost chaotic motion. Such tumbling could result from gravitational interactions during ejection from its home system, or perhaps the cumulative effect of minor impacts and outgassing events over millions of years. This irregular spin gives astronomers important insights into how interstellar bodies might behave dynamically, setting them apart from solar system objects whose motions are often stabilized by long-term gravitational influences. The coloration revealed by Webb also merits attention. While the telescope's image is translated into composite visuals, the underlying data indicates striking variations in reflectivity across the surface. Some areas appear coated in carbon-rich compounds, absorbing much of the incident sunlight and giving them a darker hue. Other regions, where water, ice, or silicate minerals dominate, shine more brightly in infrared wavelengths. This mosaic of surface types paints a picture of Atlas as a patchwork relic, an object bearing scars and deposits from a tumultuous history, possibly gathering material from different regions of its parent system before being cast adrift. The diversity across its surface makes it less a uniform body and more a geological quilt stitched together by cosmic forces. The discovery of exotic organic molecules in the spectral data adds another layer of fascination. These organics differ from those typically seen in solar system comets, suggesting they formed under conditions alien to our local environment. Their spectral signatures hint at chemical bonds and structures that may have arisen under different stellar radiation, elemental abundances, or temperature profiles. Some may even be entirely new to science, providing chemists with fresh puzzles about how complex molecules form and persist in deep space. These compounds underscore the possibility that life's raw materials are not confined to a single star system, but are instead widespread, varied, and cosmically abundant. Such a realization has profound implications for astrobiology, as it suggests that the seeds of life are strewn across the galaxy, ready to take root wherever conditions allow. The trajectory of 3I/Atlas also deserves deeper contemplation. Its hyperbolic path through our solar system not only confirms its interstellar nature but also allows scientists to trace its likely point of origin. Using Webb's precision measurements combined with ground-based data, astronomers can project its path backward, aligning it with stellar neighborhoods from which it may have emerged. Preliminary studies indicate that Atlas could have been flung from a star-forming region millions of years ago, traveling uninterrupted until its fateful encounter with our Sun. This origin story ties Atlas directly to galactic-scale dynamics, where stars, planets, and debris interact in gravitational dances that occasionally cast objects into interstellar exile. The Webb image is thus not just a picture of a rock in space. It is a chapter in the sprawling history of galactic motion. From a cultural perspective, the first image of Atlas has ignited public imagination. Humanity has always looked skyward, but interstellar objects like this provide a tangible connection to worlds we will never see. To look at Webb's image is to see not just a foreign body, but a fragment of another solar system delivered into our observational grasp.